Hi, this is Dan Mason. I am making this recording to replay a workshop that I did for the AI Engineer Summit in New York City about a month ago. It turns out that we had some AV issues and we're unable to actually get the audio and the video to sync together and get recorded for this workshop. So I'm going to do it again fresh, and we'll see if we can replicate the magic. But this workshop is about agentic workflows and MCP. So hot topic around AI engineering these days. So eager to show you the stuff that we talked about in person. I'll try to recap some of the questions as well as just the general flow of what we were showing and why it's important. So please bear with me as we get going. I want to start just a little bit about Stride. Stride is a custom software consultancy. We're based nominally in New York, but we have engineers and consultants all over the US. Also have some clients and partners in Latin America. We work with all comers. Our ideal clients tend to be either customers in need of legacy modernization, upskilling their teams, and increasingly people who want to make the most of AI. So that's really what I'm here to talk about today. So just briefly on sort of the broad portfolio of things that we do. Going right to left, Stride Conductor is a product that we are building, which is really about a combination of test coverage as well as things like fitness functions, trying to help you understand, how to make your code better day to day, sort of as a partner as you build. Whereas Stride 100X in the middle here is a modernization product and really a service where we take crazy code bases and teams who need help understanding them and then also making a plan to modernize or reduce technical debt. We use AI tools as well as very, very smart engineers to make that happen. But what I'm here to talk to you about today is the thing on the left, building AI and LLM powered workflows. This is something that I'm doing almost all the time now. We have a couple of really interesting things to show you. Everything you're about to see is real code. I can't show you actual client code for what I hope are obvious reasons. But these are real examples that we've run with real scenarios. I'll try to allude to some of the results that we've seen, but this is much more about the technical end and sort of just demonstrating how these things work and then getting a little bit into the code as well. So let's do it. Again, what we're talking about here is agentic workflows. And to be clear, I am pretty invested in these examples in LangGraph. LangGraph is a framework from LangChain that helps you orchestrate these agent workflows in graph form. I find it really, really helpful, both because as consultants, we want to demonstrate how this stuff works to our clients. It's that this is really easy to understand, I think, compared to a lot of other agent frameworks. And it also is flexible enough. You're writing the code, you own it, you can plug it into whatever you want. And so what I've done here is I've plugged LangGraph applications into MCP, right, to sort of get the most out of both sides of it, both the agent workflow and the tools. I'm also going to show you some proto examples that we built before MCP because we had a need for this framework as early as sort of the middle of last year. We built a number of examples of using a framework like MCP that we call Code API to do similar things. So you'll see sort of the evolution from where we started all the way up to where we are now. Okay. Next slide. All right, so I want to start just really briefly with some definitions. I think it's important for us to agree at least or understand where we're coming from in terms of what we mean by agents and kind of how we think this all fits together. So the first thing is I do like the LangChain definition because what it's really talking about here is just that an agent is really anything that uses an LLM to make decisions about how how your software works, right? The control flow in this case of an application. So I think that's a good way to think about it. And one reason it's a good way to think about it is because I do think that the power of AI as a paradigm is that you can define outcomes instead of process steps, right? The workflow is kind of a hybrid because you're defining the possible steps, but you're not saying exactly how to get a task done. You're leaving a fair amount of flexibility to the agents. But in particular, this idea of you're not saying how to do it, but you're giving a range of options and then allowing the LLMs to decide. I think that's really, really powerful. It's powerful, among other reasons, because it means that people who are not necessarily invested in procedural programming or the things that are to date have had to be done to make software work. Now you can do a lot of stuff really just by kind of defining the universe and making some rules, and then to some degree sitting back and watching the fun. We'll see. It's not quite like that, but there's an element of it, right? And I think that's really exciting. And the other part that's exciting is that this stuff really is fundamentally kind of Legos, right? The MCP stuff in particular, the idea is that you can take parts from wherever you can find them and you can plug them together in these interesting ways, and you can create, with a really minimal amount of your own code, some really, really interesting results. And I'll try to get into that once we get to the MCP examples later. Okay, so again, I've mentioned, kind of a handful of things about this, but I'll reiterate. So what we're doing here is very framework opinionated, right? But it works in a variety of different contexts, right? The things that I'm showing you here could absolutely be defined in Autogen from Microsoft, in Crew AI, in OpenAI agents, right? The Swarm framework. None of this stuff is specific to LangGraph. We think the ecosystem is really nice around LangGraph. It's very easy to understand. It comes with built-in observability through Langsmith. There's a bunch of good reasons to use it. And we have productionized it. There are some wrinkles when you get into the production environments, but they do work. And so, what you're about to see here is agnostic, but opinionated. Same with the models. We love Claude. Like, we use Claude for almost all of our code generation, but not all of it, right? We do have some things where we've plugged in OpenAI at client request, which I'll get to in a second. We've done some experimentation with Gemini in different use cases as well. We're happy to use whatever, and all the way down to local models. We do have a handful of deployments against Llama. Claude tends to be best at code generation, and it also tends to be really good at following a lot of the rules that we tend to define in these graphs, right? So we have opinions about it, but we can use anything. There's nothing here that is explicitly specific to any one model. Same with the stack. And again, I mentioned client environments. This stuff, most of what I'm showing you here is Python code, which could be deployed anywhere you want. Our deployments have been in AWS and GCP and in Azure. None of this stuff is specific to any of those environments, and anything you see here should work kind of wherever you need to deploy it. Evals. So let's talk about this for a second, because I do want to be really clear about kind of what is going on here and what might not be. So for coding use cases, right, we do basically treat the sort of external shell around the code as the eval, right? A combination of code reviews, by humans and AI, linters, test suites. Generally speaking, the evals are, not, is my model delivering the same code every time, right? But it is my model delivering code the way that I want it? Is it following the rules? Is it, taking my guidelines and coding standards and observing them, right? And a lot of that you can do with linters and code reviews. So we do, very much have evals in that sense, but not evals in, kind of the more classical model sense, right? Of, evaluating sort of different code snippets. We think the models fundamentally are doing a lot of that internally. For non-coding workflows, it's a combination of things like LLM as a judge. I have an example of that coming up later, which we really like. And then, human annotations, right? Is this good, right? And, how many examples do we have? We are not model trainers. We don't build models, train models, or really even do, we certainly don't fine tune, except for, very, very narrow cases where cost is involved. We tend to really just try to gather this data and then use it, appropriately in the flow. And so LLM as a judge and human annotation also sort of has an implied human in the loop. All the workflows I'm going to show you here explicitly do have humans in the loop, both to catch errors as well as to sort of validate that the flow is going well, and everything has the option for humans to intercede. The other thing to note about this code is I'm an engineer by training. I was a software engineer for about 7 years out of college. I know how to write code. I've written down in dirty code. My last, major gig was as a Palm Pilot, sort of C++ app developer. So, I know what code looks like. I am not, for the last 15 years, a professional software developer. I've been mostly a product guy with some other engineering management and corp dev things going on. So, the reason I mention this is that what I'm doing here is essentially what you would think of as vibe coding, right? I'm using Klein primarily, which is a point that I want to get to in a second here. Klein is a really, really interesting tool for someone like me, because it was one of the first to really go all in on the agentic coding approach, right? You talk to it. You don't generally write the code. If you do write the code, it slows you down, because then you have to explain to Klein what you did, or you have to have it sort of reread all the changes you made. It's easier just to talk to it. And so I really do prefer Klein. I think Windsurf is a great product, and it's sort of very much in that same ethos. I think Cursor is caught up. I think Cursor was very much not agentic coding for the first chunk of its life, but now it does have that mode in Composer, and I would put Copilot sort of behind the pack. But I just want that to be clear. When you look at some of this code, this is code that I oversaw, but I wouldn't necessarily say that I wrote it. So that's a brave new world. Okay. Briefly, there are some sample resources that you're welcome to take a look at. If you take one thing away from this right now, it's that top link, jpsj.me. That's a link to all of my personal stuff. So you can go to my GitHub, you can go to my LinkedIn, you can find all of these things from there. My GitHub is also in the second couple of links. So feel free to look at all of this stuff. I've shared everything that I can. Again, not client code, but certainly examples of the kinds of techniques that we've used with clients. Okay, let's do some demos. So this is going to be a mix of a handful of videos just to sort of make sure that we get through, kind of the older examples, and then I will jump over into real code when we start talking about MCP. So the first example I wanted to share was around legacy code. So these are real examples from clients. We have been working on helping various clients modernize things like old Java applications. So the example you're going to see here is a JBoss application from, I want to say, the early 2010s. It was old enough that I couldn't make it run, right? So I legitimately was not able to get this thing working on my laptop, but I had the code. And so what I was able to do was basically spin up a workflow in Langsmith and LangGraph, and then give it access essentially to tools to do things like reading files and writing files from the repo itself, and then running the build, install, and run scripts, right? So I just basically gave it, access to Maven commands. And by doing that, it was able to do things like read the POM file, start reading the code. It, removed a lot of the old cruft that was not necessary, given the upgrade we were trying to do, which was from Java 6 to Java 17, right? It ended up making a ton of these changes. So that entire thing on the left here are all changes that, in this case, my agent team made, right? It, rewrote Java, JSP, all sorts of other stuff. Again, it repackaged everything in the POM, and then ran it, as you can see down here on the bottom, and the example largely worked. So again, this is not the client code. We were working with a very similar application though, and we were able to deliver, very similar results. This is now working code that I can run on my local laptop and that I could have redeployed with a much more modern framework. So this kind of thing, right, is hands-on in the sense that you're supervising it, but you're certainly not touching the code unless you have to. You just, either let it run the build and install scripts until it works, or, you step in and you just say, hey, have you tried this, right? But you're not really interceding to write the code. So again, this is something where we used our code API as a way to do this, right? Our code API was a way that we connected the graph, the agents talking, and the repo itself, right? That was the bridge. Whereas in the more modern samples, we're going to use MCP to do that. Okay, so that's number one. Number two, this is a flow that we call Test Builder, but this is very much the same flow that we use in our Conductor product to add unit test coverage. The things to note here are, again, these stages, right? So these are all, and this is true of all these agent workflows, these are all, in this case, Claude, right? You could set them up as having different models behind each of them, but these really are just different, sort of localized personalities with Claude inside, given different jobs in this graph, right? And so what this ends up looking like is, again, a very similar thing where you've got, let's see if we can get this started. There we go. You've got the process of going through and defining, well, what are we trying to do here? We're trying to add some tests. What does the code look like? Let's dump the code into the window, right? The code that specifically pertains to this task that we're trying to add, right? What standards do we have around how we want to write tests, right? This is a piece of what Conductor does. It does this tailoring. And then you actually let the agents go and sort of gather all of this context, explain themselves, and then pass along to the next agent to actually do a different piece of the task. So one reason this works is because you get multiple bites at the apple, right? You get multiple chances to look at this and make plans and then review work. And it works because we're plugging it into actual tools, right? The context comes from the actual repo, right? Then I format code that I want to write and I apply it to the repo itself. And then I run the test suite, right? And the test runner here is able to run the actual test suite, right? I get a coverage report. I can then look at the coverage report and I can see, well, what failures did I have? How can I fix those failures? And then I can loop back around and do it again, right? So this is a self-healing loop that looks at, in this case, a repo and its test suite, and is going to do its best, to get to a successful state. And the whole time you have this paper trail, right? You can see what it's doing. And that's a really important part of all of these things, right? You're both getting a live view of what's going on here, as well as the paper trail for what it actually did for future analysis. So I think that's really powerful. Okay, and the last example on the pre-MCP side. So this is a non-code example, right? So in this case, this is a publishing client we were working with who was interested in using AI to translate books. And in fact, this was a pure AI solution, right? We did not, in fact, want humans involved. It was kind of an attempt to see how good we could make these translations in those conditions. So we built the same kind of basic flow as you just saw in the code side, but with a case of we're going to orchestrate and sort of put the translation or the piece of the translation we want in front of these guys, and then the translation and review loop is again giving multiple chances to improve a translation, and then when you get to a satisfactory state, you write it out and you loop back around and sort of do the next piece. And we were able, and I'll go ahead and get started here, we were able to translate something like 10,000 pages, right, with this method. And it was, something we had to supervise. I think overall, this took probably at least a couple of days in real time to get through all of this stuff. We ended up using GPT-4o Mini actually to do it because it was good enough at the translations when you kept the sizes of each chunk pretty small, and the cost was right. It was very expensive to do pieces of this with Claude. But you can see on the right that what we're doing is we're again going stage by stage, trying to gather data and then produce a plan, and then actually go in and do the real translation, and then have again a paper trail of the different pieces of feedback that are coming out of this, right? And then retranslating certain parts of it. And when you get to a place where the agents think that they're done, they write it out. Now, at that point, you could run it through another team of agents. You could have humans read it, right? None of this has to be 100% bulletproof. Agents are doing this by themselves. There's a lot of stuff you build around the workflows to make them both fault tolerant and to get you sort of the last mile, right? And make sure that you end up with the exact thing that you want. So it's a really, really interesting way, to try to do this, right? To try to get to a result which doesn't have to be human babysat, other than just kind of making sure that it's getting through all the steps and that you can look at the output afterwards. So again, really, really powerful. And all of this predates what we started then doing with MCP. These were tools that we had to build ourselves that essentially talked, to our code and to this content. Okay, so now let's talk about MCP. So you will notice this is a very simple template that looks a lot like that first one we talked about, the package upgrader, which was doing legacy code modernization with repo tools. So this is a genericized kind of version of that. So LangChain has this concept of a React agent, right? Which the pattern is basically just the model is attempting to accomplish a task on behalf of a user, and there are tools that it has access to. Now, in the original sample, the tools were hard-coded, right? You had to say specifically what tools you wanted to make available, and you had to write the code for them. In the MCP version, you don't have to do that. What we do is we plug into essentially a gateway that has configured servers, and then we can use whatever tools we want to at that point, right? And we can actually just provide them and essentially auto-discover their capabilities. So that's what I want to show you now. So let me just get my mouse. Okay, I'm going to get out of full screen. All right, let's exit slideshow. Okay, so first I'm going to show you what this looks like in practice. So I've got a running version of this right over here. So I have helpfully pre-populated a question, which I'll move my face so you can see a little better. So in this case, I am a Washington, D.C. football fan. It's been a very long 30 years. But one thing that I thought would be fun is to see if using a couple of tools, we'll get into in a second, can this agent team actually go across sort of the different tool capabilities that it needs to answer a question that I have and to take an action on my behalf, right? So the example here is, I want you to find out whether the Washington Commanders played in the 2025 NFC Championship game, right? So that requires, in this case, searching the web, right? It's not knowledge that even the most modern models should have fully in their head, right? If they did, I want you to write a file, right, that says the Dallas Cowboys are losers, which they are. There's no real doubt about that. But, what I'm looking for is to see if the model can figure that out. So here is what the code looks like, at a high level to do that. And I'll show you what it looks like to run it in a second. The first bit is this configuration piece. So for those who've played with MCP, you understand that this is how you configure these things inside of Claude Desktop. The same format can be used really anywhere you want. So I built, as part of this application, a gateway that would allow you to configure whatever servers you want within reason. And, there's still like, a fair amount of work just to get these things configured. And, you can also write your own, which I'll get to in a minute. But once you configure them, these tools are going to be automatically discovered, right, by the LangGraph that's actually going to be talking to this gateway. And so I've given it two things. I've given it access to the file system, right? And I've basically said, you can have access to this directory. You can, write and read and kind of do whatever you want. I do not recommend that you give it access to /, although if you do, that could be a lot of fun. If you go down now to the second tool, you got Google search, right? So I'm giving it access and I've deleted my keys here, but I did have to go and make, a Google API key and a custom search engine. I happen to have one lying around for a different project. So I've given it both of these tools. And then I've basically just said, okay, we're just going to plug this into the graph, right? And the graph here is the simplest possible graph, right? The tools are basically just the tools that are going to be discovered by the MCP server. And I define this graph kind of the way that you just saw it in person. And then I just go. And the thing that I wanted to point out here, and this is a question that came up in real time, there's no prompt intelligence about any of this. I'm literally just saying, you are an AI assistant, right? This is the simple, boilerplate thing that comes out of this sample app. But even with this prompt plus MCP, I can get some really interesting stuff. So this prompt plus the tools that I'm exposing through the MCP server are going to produce a really fun result. So let's go back here and let's see what happens. So what you should see is that this is going to try to make a call out to Google search, right, to determine essentially, whether it can figure this out. It's going to get back some results, and I'll show you what those are in a minute. And then it correctly determines a couple of things, right? First of all, going up here to the top, it did this search and, predictably enough, it looks and says, okay, yes, looks like, the Philadelphia Eagles and the Washington Commanders played in the NFC Championship game, right? So, we've quickly confirmed what we wanted to know. The second thing we asked was write a file. Now you can see here, it tried to write a file to an invalid path. It didn't actually check what path it had access to write to, right? And so it attempted to write this file out. It got an error. Now this error helpfully points out this is the thing that you can actually write to. So then it goes back and it says, okay, well, let's see. So is this directory allowed? Awesome, right? Now I know it is. I can write a file now to that directory, which has the content that I want. I successfully write it. I give a little, summary right here. Yes, they did play in this game and I did what you asked me to do. And if I go back over here, I believe you will see the thing that I asked for. This is obviously not a super complicated example, but I hope you can see the potential, right? What you can do is you can link together different tools and different capabilities with very, very little code and very, very little prompt, and then really just sort of focus on the business logic and the things that you actually want to get done, right? So I think this is really, really interesting and really powerful. And it's really the reason that I'm excited about MCP. And you can imagine this is very similar to what we had to do. We just had to define all the tools ourselves that we wanted to expose in terms of writing to repos and things like that. And so in the next sample, I'll show you kind of what happens when you get a bit more sophisticated and specific to the coding use cases. So we already saw the code, so we'll skip right past that. This next sample, this is a tweet from Brian Armstrong, the CEO of Coinbase. A little dense, but the basic idea here is just they're using AI in all of these ways, and he's correctly pointing out that one thing you could do and probably should do is to start to use AI to attack your feature backlog, right? Start with the things that are either bugs or easy to do, and but ultimately you can have essentially draft PRs for all sorts of things, that you want to build, but which you just haven't explicitly either prioritized or fully fleshed out yet. So there's different versions of this, right? There's a version where it's everything and ready for dev. There's a version where it's everything in the parking lot. There's a version where it's everything, that hasn't been fully designed yet, but maybe you just write the code anyway and then you refine it, right? There's a whole bunch of ways to do this. And so it turns out we had a very similar idea. I'm not saying we necessarily had it before, Brian made his tweet, but this code sample does predate that. And this was actually also part of a hackathon that a colleague of mine at Stride and I entered with Anthropic back in the fall. And so the idea here, again, this code is out there if you want to take a look at it. The idea is that you've got a workflow that has MCP at the middle, because MCP is how you're accessing essentially the repo itself, and is going through a kind of a similar flow to what you saw in some of the older code API samples. An orchestrator that's gathering context. In this case, a planner, which is going to go and plan out the code. And then a coder who's going to do it. Now, the big wrinkle here is that it's not just one sample that we want to do. What I'm telling it is, hey, here's what I want, right? Over here on the right, you're seeing, update my app to, add this feature, right? And we also gave it a linear ticket. Then it's going to go and use a GitHub MCP server. And it's going straight to the repo. I had to give it a key, right? But it's going straight to the repo and it's reading a whole bunch of stuff. These are all config files. And in this case, a mix of JavaScript and CSS and things like that. And you can see here, not a complicated app, but it's navigating through all the things that it thinks that it's going to have to do. It reads the CSS, it reads the JavaScript, it has an idea now of what's going on in the current code base, and then it's going to pass it along, right, to the next agent. Now, one fun thing which is happening right now is that it also tried to call like a weird MCP function that I gave it, to define a memory graph, and that failed. But it didn't matter because it figured out that it basically had enough stuff to proceed anyway. So it just moves on, right? It's resilient to that sort of error when it doesn't require it. to actually get its work done. So now we're into the planner part. Now, again, the fun part of this is that the planner has explicit instructions to do more than one approach, right? Here's 3 different ways that you could solve for this thing. And then the coder has a specific mandate to do those 3 different branches, right? To actually, do all of these things. And you can see here, some of the language here is a little spicy, but it's partly just to make sure that we know the graph knows how to pass this stuff along from stage to stage. There are more mature ways to do that now. But so this whole flow, right, is basically built to try to get multiple versions of the same feature, which is something that you would almost never do, at least not at the development level, with real coders. And so one thing I want to move on and show you here is this is also not a unique concept. This actually just came out, I think, a few weeks ago, and I love the idea, so I wanted to throw it in here. The idea of a chaos coder, right? You tell me what you want, and I will make you a whole bunch of versions of it. And then you just pick the one that you sort of like and go, throw the other 8 away, and then do it again, right? And you create this explosion of different variants of these things. It's cheap enough to write this code that this could be a really viable way to develop something. Now, granted, is this better than the really smart stuff you can get out of Lovable and tools like that? Maybe not. But the point stands. You don't necessarily need to do the kind of upfront prioritization and discovery on everything that you're doing that you do today. Like, discovery is still important to make sure you're building the right thing, but the details and the variants, you have a lot of power here, to do interesting stuff. Okay, so let's see the code for this one. So let me do the same thing here. Exit slideshow. Okay, so the code for this one is a little different, but not too much, right? So the first thing I'll show here is just what you do to set up the graph. So the graph here is really pretty simple, and this again is LangGraph syntax. But you define what the graph is. You add nodes to it, and then you add edges. And some of these edges always execute, and some of these edges are conditional. It depends what's going on and sort of where you're going to go. And this routing function is fairly straightforward routing, right? Like in terms of passing things along to the right agent at the right time. Trying to route based on whatever the current job is. And so, once you have all the context, the orchestrator passes it to the planner. Once you have the plan, you go to the coder. Once the coder is done, you check with the orchestrator and make sure that it's all ready. So that kind of logic has to be here, but it's not very complicated, and you even could move it out to a config file if you really wanted to. It doesn't have to be actual code. Sorry about that. There we go. Okay. Sorry, I have to update my Mac OS. So we're back to the graph. So this is part 1. The other parts really are largely prompt, right? And I'll show you the MCP server in a second as well, just so you can see it. The prompt here is not super complicated, right? And in fact, the main thing that you actually have to do, like a bunch of this is just saying, here's the tools that you can use to do certain things, right? Use this tool to route. That's an enhancement that we made, after the hackathon. You can see here, we're offering the option of using either a local server for Git or using the GitHub one. That's really up to you, and it's something that you can expose depending on which keys you want to give. The main other one is actually just clarifying the roles of the agents. The hardest part, because this is all Claude, who is basically all-seeing and all-powerful, is that you have to tell it, hey, your job is only to do this orchestration piece. You don't do the other parts, and if you do them, you'll mess up the workflow. There's ways to get around this in sort of more creative prompts, and also sort of taking away some of the tools, right? In my case, I've kept it very simple. But this is kind of one of the wrinkles of this kind of flow, is that you do have to be critical about, hey, make sure that you leave room for the other guys to do their jobs. Likewise, in the planner, you give good examples. You say, hey, this is, I want you to make 3 versions of this thing, be very clear about what they are. Here's how you format it. And then fundamentally, that's enough, right? All you have to do is then give it the space to do its job. And likewise with the coder, your job is to make a branch. Make sure you make a branch for everything, right? This is basic stuff, but recombined in this way, you can produce really interesting things, right? So, again, just, as examples go, I like this one a lot. I think it gives you a sense of what the power really is here. Okay, let's go on one more. Okay, so last example before I get to my finale here. This is a side project. This is just something I've been working on myself, which I'll try to show in just a second. So I'll jump out of slideshow. This is essentially a college counselor in a box. And I have 3 kids, one of whom is starting to think about college. So it's definitely something that is on my mind, right? And the thing that I did here was both, vibe coded almost all of this with Klein, right? But, to a degree where I understood what was going on, I accept it all a lot of the time. But I do understand how this is built. And I'm able to maintain it using Klein. But I also plugged it in to a couple of different interesting tools, right? So I have the same basic idea of like a search tool. This is implemented via MCP. I didn't do any of this with LangGraph for what it's worth. I wanted to make sure that I could do this with no agent framework at all. So this is all just custom code that Klein wrote, essentially to have an agent who does these college recommendations, calls tools, gets back tools. This is a thinking agent that actually, thought before, sort of thinking agents were a thing. I built this back in right around Christmas. Then also takes this stuff and then processes it further and uses an MCP server to actually generate, a map, right? And in this case, a map of where, I've defined sort of all of these colleges that I want to look at. And if I click on these things, I will get, some details, right? Some links, right? I can pull all this stuff out and then, save it in interesting ways. So this is a way to use something like MCP and custom application code to produce an experience that, it's got a lot in common with something like deep research. But I think, it's got more utility, right? It's something it's easier, I think, for humans to use. I love this example. I'm really enjoying it personally. And it's just a way to make sure that, we don't get overly invested in these frameworks. You don't need them, but they can make things, a little bit easier to get started with and then to explain. Okay, last one. So this is my favorite because this is actually a project that's still ongoing that we're working on for our client. This is a telemedicine assistant. And the interesting thing here is not this graph, right? Which you can see here is pretty simple. So I'll get into what this does in a second. It's really the broader system, right? So the broader system that's going on here is real software that, just has an LLM at the core of it, right? And so in this case, we're talking about essentially a support system for helping people take medicine regimens from their homes. And so the primary interface is text messages. We've got the ability to, receive and send text messages. We've got the ability to save, kind of the current state, like the conversation we're having with someone, as well as whatever we know about them, to a database. We've got the ability to, this dashboard down here is where the humans can get in the loop, right? Let me see what's going on here. Let me intercede if I need to. But the core of it is really going on inside a LangGraph. And the interesting thing here is we're using reflection, right? In this case, the idea of there's an agent whose job it is to come up with the next thing to say, and then there's an evaluator whose job it is to evaluate what that thing is, right? And try and essentially to look at the complexity of it. Is this complex enough, or is the LLM uncertain enough that it makes sense for a human to get involved? And in this case, fairly straightforward, but, we have a whole bunch of logic here, right? That is also backed up by, this real software. And so to go back to the whole system design, right? We still have humans in this loop, right? We're not replacing the humans, but what we're doing is radically increasing their capacity, right? And so we're able to take, a team which used to only be able to support X patients, and now we can support something like 10X, right? I don't think we know the exact numbers, but, it makes essentially the people you have into supervisors, into expert help for the LLMs when they need it, and into overseers where they can look at what's going on and they can try to understand the system health and get involved before anything goes off the rails. So super interesting. We're really, really happy about this one. Okay, a couple of final thoughts. The first one is really just, again, I hope the thing that pops out about MCP is that it makes your code and your prompts a lot shorter, right? I think it also makes them better because it allows you not to really focus on, instructing them on how to use all these tools, right? It just says, here's the tools you've got, here's what I want, figure it out, right? And you can produce something that would otherwise have had to be a lot of custom code, with really just a handful of configurations and some better prompts. So it lets you focus more on the workflow and the business logic. MCP registries. So at the Engineer Summit, Anthropic definitely said pretty directly that they're looking to build an MCP registry. This would be akin to something like an NPM or a pip, right? Now, there's a bunch of reasons why this would be really good. So right now, you're pulling MCP servers off of GitHub. If they change, your app changes. There's a bunch of reasons why this is potentially dangerous. And the ones that we've used, we're largely writing ourselves. So when the registry comes, then you're going to be able to pull a certain version and lock to it and also, be a bit protected from those kinds of changes. So I think that's really going to open up a lot of hopefully acceptance and adoption. The other thing, and I didn't really sort of overly hype on this, but I'll talk about it a little bit now. You can create some crazy productivity with these workflows. Okay. And so the three examples I can think of is that we had one project on the test coverage side where, we had essentially a task estimated at a developer year that came down to roughly a developer month, right? Because of these tools. It's not free. It doesn't mean like all of a sudden, the robots do it and it's done, but it makes things that either weren't doable before or were ROI negative, it brings them into the realm of possibility. Likewise for things like modernizations, right? A 2-year project, maybe now it's less than a year, right? And certain tasks, which used to take 3 days, take 3 hours, right? We are adding the productivity back into these things, which fundamentally either were just giant time sucks or weren't even getting done because they were so hard and so tedious. And the last one, the example that I just showed you, this enables this team of telemedicine support people to scale in a way that they just couldn't before, right? They just could not add enough people to support the patients they wanted to. And now with this new model where humans are supervisors and humans are really monitoring and managing the system instead of pushing all the buttons, enables them to do that. And MCP helps you build those workflows faster, right? The whole thing is if we can just pull some of these tools off the shelf, we don't have to write the custom code that goes into every single step of this process. And lastly, again, if you're interested in any of this stuff and you want to follow up, that's my website. Just go and check out both my GitHub for the code as well as any other channels that might be of interest. So thank you so much for watching and for joining me here. I really appreciate it. And if you have any questions, please feel free to reach out to me on any of these channels. Thank you.